Okay friends, now we will discuss another problem by using Gaussian quadrature method, right? So question is, evaluate the integral by using Gaussian quadrature. And the equation is integral -1 to +1 f of x dx. Now if you look at this problem, they have not directly mentioned in which point you have to find, that is whether it is you have to solve it by 1 point or 2 point or 3 point. It is not directly mentioned. So what you have to do, so before solving you have to find that point. So in order to find that point, so you have to use the equation that is, as I mentioned earlier, the equation is that is 2n minus 1 is equal to highest, that is 2n minus 1 is equal to highest polynomial, which will be given in the question, right? So this is the general formula, as I said earlier, right? 2n minus 1 is equal to highest polynomial value power. So if I take the equation, so which is highest power, that is power is mentioned as given as 2, that is 2n minus 1 is equal to this power value 2, that is 2n is equal to 2 plus 1, that is n is equal to 1.5, which is approximately 2. So you have to take the n as is equal to 2, so you have to solve it by 2 point Gaussian quadrature method, right? So for 2 point Gaussian quadrature method, the value of x1 is plus 0.5773 and x2 is minus 0.5773. Similarly, w1 is equal to 1 as well as w2 is equal to 2. Now, so the general equation is like this. If it is a 2 point, so the equation will be like this, that is 2 point integral minus 1 to plus 1 f of x dx is equal to w1 f of x1 plus w2 f of x2. So what you have to do is you have to find the values of w1, and similarly you have to find the values of w2, and you have to find the values of f of x1, you have to find the value of f of x2, and after finding all this, if you do the summation, you can be able to find the overall result, right? So now we will find it w1 f of x1 as well as w2 f of x2. So in order to find w1 f of x1, I have to find f of x1 first, right? That is f of x1 is equal to x1 square, that is from the above equation, right? The x1 square, that is the value of what is the value of x1? It is nothing but 0.5773. So take it, that is 0.5773 the whole square. If I do the squaring, what I can get is f of x1 is equal to 0.333, right? Now once if I found the value of f of x1, what I have to do is I have to find the value of w1 f of x1, that is what is the value of w1? It is nothing but the 1, right? So 1 into what is the value of f of x1? It is nothing but 0.333, right? So if I do the multiplication, that is w1 f of x1 is equal to 1 into 0.333, that is equal to 0.333. This is nothing but my w1 f of x1, that is my equation 1, right? Similarly, what I have to do is I have to find it for w2 f of x2, right? So in order to find the value of w2 f of x2, I have to find f of x2 first, right? F of x2 is equal to x2 squared. What is the value of x2? I have to take it from the previous step, that is x2 is minus 0.5773, right? That is minus 0.5773 the whole square. If I doing the square, what I can able to get is, that is f of x2 is equal to 0.333, right? Once if I find the value of f of x2, what I have to do? I have to find the value of w2 f of x2. So we know the value of f of x2, right? What is the value of w2? It is nothing but the value 1, right? So w2 f of x2 is nothing but 1 into 0.33, right? So the overall w2 f of x2 is nothing but 0.333. Now, so once I have found the value of the w1 f of x2 as well as w1 f of x1, what I have to do is I have to do the summation, that is w1 f of x1 plus w2 f of x2, that is equal to 0.333 from the first equation and plus 0.333 from the second equation. So when I doing the summation, what I can get is the overall answer is 0.666. that is nothing but the integral value, that is minus 1 to plus 1 x squared dx is equal to 0.666. so this is the answer by the Gaussian quadrature method, right? So again, what I'm going to do is I'm going to compare this value with the actual integral values, right? So in order to find, so equation is I is equal to integral minus 1 to plus 1 x squared dx. So do the integration, that is while doing the integration of x squared, what you can get is x cubed divided by 3, limit is 1 minus 1. So I am going to substitute the limit, that is upper limit minus lower limit, that is upper limit is 1 divided by 3 minus of 1 divided by, that is minus 1 the whole cube is nothing but minus 1, right? So minus of minus 1 divided by 3, that is if I simplify this, I can able to find, that is I can able to get 1 by 3 plus 1 by 3, that is equal to 2 by 3. While dividing this, I can able to find the value of 0.666. so by the actual integral method, what I'm going to get is the value as 0.666. now I'm going to compare both the results, that is the results of Gaussian quadrature method and the integral method. When you compare this, both the results are exactly getting same, so hence it is proved. Hence it is proved by both the methods. Thank you.